Hi, it's Mr. Banish, and in this podcast, we're going to be looking at what is life. So we're going to be taking a look at that all-important question, what is life? And in the picture, you can see that I got a couple of different images. I have a dog that's located right down here. I've got a cat that looks very similar to ours at home, Snickers. And then I also have, down at the very bottom here, I have a tree. And so we're going to look at what all of these things have that make them alive. The first thing we have to do is we have to give a definition to organisms. And so organisms are basically anything that is alive. A lot of times we think of ourselves as being an organism, but you also have to think about things like dogs, cats, plants, bacteria. All of those things are organisms because of the fact that they're living. And there are some characteristics that all living things have. So things that might be like cellular organization, chemicals, energy, respond to their surroundings. They are able to grow and develop, and they are also able to reproduce. Down at the bottom, we have a couple of images. Like here we have some black-eyed Susans. They are part of the plant family, but they all share these characteristics of cellular organization, chemicals, energy, respond to their surroundings, they grow and develop, and they reproduce. Just like over on the side over here, where we have the butterfly, the monarch butterfly, this also fits into the category. So anything that is living is going to share these characteristics that we just had mentioned. So looking at them specifically, cellular organization. When we talk about cells, what we're really saying is that it's the basic unit of structure and function for organisms. So each organism has some sort of structure to it and has specific functions. And so we call those cells. There are two different types of ways to describe a cell. We refer to them as being unicellular. And when we use the term uni, what we're meaning is one or single-celled organisms. And over here on the side, that is an example of bacteria. And so if you were to look at that, you would say that, boy, each one of these is a single-celled organism. And then down at the bottom, you'll also notice that we have multicellular, meaning multiple cells or many-celled. And this is an example of a human cells that are located inside the stomach, and as you can see, each one of these right there and there and there and there, each consists of a cell. And so what we do is we describe them, as long as they have cells, then it has to be living, and it can be either unicellular or it can be multicellular. Chemicals is another characteristic that all living things share. When we're looking at this, we're talking about chemicals. It can be different types of, for example, water. We know that water is made up out of H2O, 2 hydrogens, 1 oxygen, and that's a chemical. That's chemically combined. We could be talking about, just like in this image, we could be talking about things like carbohydrates, or we could be talking about lipids. And both of these are different types of chemicals, one that gives energy and one that attaches the cells together. And so those chemicals are responsible for keeping the organism alive, and as long as they have chemicals, they would be considered a living thing. Energy. All cells use energy to perform specific tasks. And up at the top here, that is a book. I know it's a little hard to see, but in order for you to be able to read a book, you need to have cells that are going to be functioning to move and to comprehend, and so those cells are responsible for that. Also for digesting food. If you are finishing up with dinner, or if you're at lunch or breakfast or having a snack, basically what happens is that the food has to get broken down and the nutrients have to be pulled out. And so when we talk about that, what we're really referencing is how are the cells going to work to break that down? How are they pulling out those nutrients? So energy is an important characteristic that all living things share. Organisms have to be able to respond to surroundings. Okay, so there's a response to a surroundings, and we refer to a response to a surrounding as being something has to have a stimulus. So it's a change that causes an organism to react. Something like temperature, or light, or sound. Those are things that would cause you to react. If it's cold outside, you'd put a jacket on. If it was dark in the room, you'd turn on a light. If the music was loud, you'd turn it down. And so those are all different ways that you would react to a particular situation. The response is the reaction to the stimulus. So going back to our example of temperature, if the temperature is cold, your response would be to put a jacket on. If it's dark in the room, your response would be to turn on the light. If the music is loud, your response would be to turn it down. And one real example that I know has happened to me, and I'm assuming it probably has happened to you at some point in time, is the fact that you knock over a glass of water. And your immediate reaction is kind of this jump back type reaction, like, oh boy, what did I do? And immediately you quickly grab a rag, or you try to get the water cleaned up and turn the cup right side up. But that's a response to a stimulus, and the stimulus is the change that happens. So the glass tips over, the response is to immediately try to pick up or clean up the water right away. So response to surrounding is something that all organisms must be able to do. Growth and development. All things have to be able to grow and develop. Growing and developing are two different terms. When we talk about something growing, what we're really talking about is it's getting larger. And it's not changing anything other than it's just becoming bigger. So when I think of growth, the immediate thing that comes to my mind is if I'm at home and I'm looking at my grass, and I might cut the grass on a Sunday, and over the course of the week, I'll notice that the grass continues to get taller and taller and taller until eventually I cut it. So I would say that the grass is growing, or we'd say it's a growth. So because of the fact that all it's doing is becoming larger. Developing, on the other hand, is when you are changing the process to basically become more complex. And so over on the side here, I have this cute little guy that is flexing and showing us biceps. But what that really is showing is the fact that when you were a little kid, you were developing. And as you continue to get older and older, your body is changing. Your muscles are getting bigger, your arms are getting bigger, everything gets a little bit more complex. And so that little example on the side is a little guy that will slowly develop. They're going to grow because of the fact that they're going to get bigger, but they're also going to become more complex, meaning that the cells are also going to develop and they're going to get much more defined as you go further along. Another phase is reproduction. Things have to be able to produce offspring. And a couple examples that are up here, these are robin's eggs. The robin's eggs are laid, and that's their way of reproducing to more offspring. And another example that people don't often think about is that right there. Those are seeds that are found inside of an apple. And an apple, that's their way of reproducing. So the apple will fall off the tree or something will eat it, and the seeds will eventually, well, hopefully, end up back into the ground, so that way, if the conditions are right, they will be able to grow. So reproduction is a major part of characteristics that all living things share. Now, before we move on too far, those are the characteristics of all living things. So they all must share those in order to be considered living. The next part of the section talks about life coming from life. And I know it seems kind of funny for us to think that things would come from non-living things, but it's actually true. People actually had this idea that's down here at the bottom. They called it spontaneous generation. And it was the mistaken idea that living things can arise from non-living sources. And there was over here, this is Francisco Redi. He was a person that was trying to disprove this idea. This idea that living things can arise from non-living things. So what he did is he set up this experiment. There was some raw meat that was in here, so that was the raw meat. And what happened is that the flies would come and actually develop there would be little maggots that would start to grow on the meat. And what people thought was that that meat developed all kinds of maggots because of the fact that the meat was actually giving life. And so what happened is this experiment got set up. It was a controlled experiment where they had one open container with a piece of meat in there. There was another container that was completely closed off, so this was a cap that was on the top. And then over here they put some type of cloth over, so that way they could still be able to smell the rotting meat. And what they discovered in the course of the experiment was the fact that when it was completely closed off and there was no scent that was able to come near or attract any of the flies, no flies came. And so what we'd also discovered was that if there was a cloth, the cloth attracted the flies to be able to come, and as those flies came, they weren't able to get at the meat, and so there were no maggots that developed, but they were attracted to the scent. And then over here where the top was available, or it was completely off, what we discovered is that the meat actually developed maggots. And so this was the first idea to help disprove spontaneous generation. And of course, like a lot of science experiments at the time, it didn't go over very well. And so we also enter in another character. His name was Louis Pasteur, and he ran an experiment that also tested the idea of spontaneous generation. And in this case, what happened is that there was a type of broth that was put into this flask and another broth that was in here. One of them was boiled to kill off any of the bacteria that might be in there. And the one that was over here remained, what happened is that there was no boiling that was done. And what was discovered is that if the boiling was done, there was no bacteria that grew. If there was no boiling done, then the bacteria did grow. And so what it showed is that if this was nothing was able to get inside of it, and it was boiled, the bacteria was no longer available to grow. And if there was contamination right from the beginning, the bacteria would grow. And so the two experiments helped to prove that this mistaken idea that life cannot come from something that is non-living. So what we really need to understand about this is that life comes from life. Okay, we need to have a living thing that is going to give life to something else. And that's a very important concept because at the time, people didn't understand that. Finally, the last part of the section talked about needs of living things. So there are 4 different needs of all living things. There is food, which we all know that you need to have in order to survive. But there are 2 different types of ways to get food. There is autotrophs. Okay, autotrophs are ones that can make their own food. So up here you can see I have provided you with an example that is it's a plant, and it is taking in the sunlight, and it is using photosynthesis to be able to make its own food. The other one is heterotrophs, and a heterotroph cannot make its own food. And so we are examples of heterotrophs. We are unable to make our own food, so we have to either go to the store or get it, or some of you might fish, or some of you might deer hunt. But basically, we can't make our own food. We have to go and be able to get it. And then finally, another one is water. All things need water, so you got to make sure that you have water. And living space to be able to get food and water. So if it's real cramped, people will move from that space. And then finally, stable internal conditions, which is basically the maintenance of your inside. So an example might be body temperature. It gets cold outside. Your reaction is to put on a coat, or if it's super cold, what you'll do is you'll start to shiver. And if it's real warm outside, your body will start to sweat, and you'll cool your body that way. And so these living things or organisms need to have these four in order to survive. So basically what we learned today is that there are characteristics that all living things share, and there are four things that all things really need in order to survive. And then we also were able to prove that spontaneous generation is a mistaken idea, and that life has to come from life. And so that's it for here. We'll talk to you later.